we're going to continue the video that we left off earlier. So we determined that in this picture we have a simple cubic lattice structure. And we determined also that there is an atomic radius of this compound. Now we're asked the edge length and the density. So even though this is a simple cubic lattice, because that's what all the corner atoms are telling us, all the corner atoms, all the nickel is only at the corner. There is no nickel on the faces and there is no nickel in the center. So this is a simple cubic lattice. But for edge length, we would not simply use L equals 2R. But if we draw out our picture in bigger detail, we realize that the edge length and the radius relationship is more resembling that of a body-centered cubic lattice. So you could do the derivation and all that to find the length, but I'm just gonna steal the formula that they derived for the body-centered cubic lattice. But instead of writing 4R as in the formula, we know that 4R is where all of these atoms have the same size. So you could say there is 4 of these same radiuses. That's not the case. So we're just not going to use 4R, and we're going to expand that into the R's, the radiuses that we actually have, which in our problem here, we have 1.15 for nickel, so that's green. And then we have 1.32 as well. So to account for that, 2 of that, and then there's 1 radius and 2 radius. That's how we got that. And then our solution for edge length should be 2.85 in this unit, which is equal to 10 to the negative 10 meters. Okay, now we're asked the density. So density, we're gonna get it in grams per centimeter cubed. So while we're here, I'll just convert this into centimeter cubed. And then convert it into centimeters. Which will give us and as we discussed in the previous video, how we get density has been outlined. So mass is determined by the shape of this lattice, this cubic lattice, and we determine that it is a simple cubic lattice, okay? Be really careful here. So that's 1/8 times 8 of these 1/8. So notice how even though this looks like a body-centered cubic in terms of radius and length, but because all of the corners are only a nickel, and nickel is only present in these corners and not anywhere else, this is a simple cubic. So I would always counsel you just draw it out, because this writing can really throw you off, probably. Okay, so this would be 1, as it is a simple cubic. And then we're going to get the mass of Ni and Ti. They're a 1-to-1 ratio. So that's going to get us the mass, and then divide it by Avogadro's number. So we're going to get 1.77 times 10 to the negative 22 grams per atom. So that would be, got this from 47.87 plus nickel 58.69, so that's the total atomic mass for this unit cell, for this, and then we divide it by Avogadro's number to find the number of grams per atom. And now the volume is 3 times the edge length, so we're just going to pull our edge length in here. And this is in centimeters, and then cube this, which will get us, and this will be our density.